Hi everyone. Today we'll be going over problem number 4 from the fall 2022 midterm. So let's start reading through the question. So in a previous homework, we saw a recursive version of remove last, which returns a new list identical to the input list S, but with the last element in the sequence that is equal to X removed. So that was like a lot of words. So let's look through some of the example cases that they provided to get a sense of like what this function actually does. So in the first example, the so S is equal to an empty list and X is equal to 1. And since there's nothing in the list, there's like we can't check to see whether 1 is there, right? So we just return an empty list. But in example number 2, now we have a list with the element 1 inside, and 1 there like we're looking for the value of 1, and that's inside the list. So we remove that and we end up returning an empty list. Now, in example number 3, we're given a list with 2 ones inside, but we only want to remove the last time that 1 appears. So this one right here. So we remove that and we end up returning just a list with that value inside. So these 3 examples are here basically do the same thing. But these last 2 are like especially important because we can see that there's like duplicates. So let's just check the last example just to make sure we understand. So we want to remove 5, and we see that 5 appears 2 times right here, but we only want to remove the last time 5 appears. So this 5 right here, so we remove that, and our final list should be including the values 3, 5, 2, and 11. So Jessica tried to write an iterative version of this function, and below is her code. And in part A of this question, we want to see whether the code will execute the expected behavior. So whether Jessica's code will return the same output as all of these examples do right here. It's kind of like unnecessary to go through every single example just to make sure like her code works. So what we should do is use like this last example right here because it's the most comprehensive. So in that example, X is equal to 5. And S is equal to the list 3, 5, 2, 5, 11. And we have a variable called new list, and that's assigned to an empty list. And I'm assuming that this list will be containing all the values we want to keep. And we have a for loop that searches through every single element in S. So the first element is equal to 3. And we want to check if 3 is not equal to, so if lm is not equal to x, we want to add x inside, we want to append x to a new list. So right now, lm is equal to 3, and 3 is not equal to 5, right? So we want to append 3 to new list. So append that. And the next value in lm, or the next value in s, is 5. So lm gets assigned to 5 now. And 5 is equal to 5, right? So we don't append that. Now our next value in lm is 2, and 2 is not equal to 5, so we append that. And let's keep going. So 5 equals to 5, so we don't append that. Our last value is 11, and 11 is not equal to 5, so we append that. So our return list is actually 3, 2, 11. And let's check whether this output matches with that output right here. And clearly they both don't match, right? Because there's a 5 here, but there's no 5 in our output. So we know that this option is wrong already because the code is incorrect. And now let's see why Jessica's code doesn't operate the way it should be. So in example, option number 2, no, this code is removing only the first element of S that is equal to X. But this is not true, right? Because if that was the case, then we would just remove this, but we would keep that 5. And as a result, that option is wrong. In option number 3, no, this code is removing all elements of S that are equal to X. So let's check. We want to remove 5, and we see that both 5s are gone from our output. So that matches with option number 3. And let's just check the last 2 examples, not examples, the last 2 options just to make sure option number 3 is actually the correct one. So in 4, No, this code is removing elements of S that are not equal to X. Well, our Jessica's code is not doing that in the first place. And option number 5, no, this code is wrong for a different reason not listed here, but nope. Option number 3 has the correct reason why. So these two options are wrong. And option number 3 is the correct answer for part A. So moving on to part B, Amit also tried to write an iterative version of this function, and his code is below. So basically, we're doing the same thing we did in part A, so checking whether the code returns the correct output, but with the different code that we're given now. So using the same example, x equals to 5, s is equal to 3, 5, 2, 5, 11. So new list is now assigned to s.copy. And what s.copy does is that it takes a copy of s. So since s is our list right here, we'll be copying that. And now I is equal to 0. And it says while I is less than length s. So length s is equal to 5. So this is true, so we enter our while loop. So we want to check whether s of I is equal to x. So I'm going to write the indices for s above just to make things a little bit easier to comprehend. Okay. So s of 0 is currently equal to 3, and 3 is not equal to 5. So we don't enter this stuff here, and we just do I plus equals to 1. So now I goes to 1. So s of I is equal to 5. But 5 is equal to x, right? So 5 is equal to 5. So what we do is we do new list.pop I. And what this does is that it removes, at index I, it removes that value. That's what .pop does. So at index I, so I is equal to 1, so right here, we remove this. So now new list is equal to this, and that's what we do, return new list. So our return output is 3, 2, 5, 11. Okay, now let's check. Does this match with this? No, right? It might look, so if we weren't looking too carefully, we might have said, yes, the code works, but it doesn't, right? Because there's a 5 here and we don't have a 5 there. Our 5 is right here and they don't have a 5 there. So automatically, this first option is wrong. And now let's see why the code is incorrect. So no, this code is removing only the first element of s that's equal to x. And we can see that that's true, right? Because in our original list, we had a 5 here, and now we don't have a 5 here. And that was the first time that 5 showed up, right? So this is correct. And then let's check the last 3 options just to make sure. No, this code is removing all elements of s that are equal to x. Well, that's not true, right? Because if that was true, we would also remove this 5 right here, but it's in our output, right? So this one's, oops, not that. This is wrong. And no, this code is removing elements of s that are not equal to x. That's also false. And option number 5 is false because we already know option number 2 is correct. So the final answer for part B is option number 2. Hopefully that helped. Good luck.